Welcome back. We're going to start working with the standard normal distribution and regular normal distributions. But we're first going to find out how to find probabilities using the standard normal probability distribution, the distribution we looked at last time. That's the distribution who has a very special variable name we call z, and it has a mean of 0 and a standard deviation of 1. So this is our standard normal random variable z and its probability distribution. And as you can see, I went 1, 2, 3 standard deviations to the right and to the left of the standard normal distribution where the mean is 0. And a standard deviation actually has the value of 1 unit. So I know that the probability between 0 and 1 is 34% based on the empirical rule. Since we had learned that between 1 and -1 standard deviations, 68% of our data lie. So it holds true for this distribution too, that 34% of our data would lie between 0 and -1 standard deviations from the mean. And that between 2 standard deviations from the mean, 95% of the data lie. So between -2 and 2 standard deviations, 95% of our probability or our random variables would lie. So what problem we came up with the last time we talked about the normal distribution is, what if I want to know what's the probability of being 1.2 standard deviations from the mean? How do I find out the probability of that? That's where we either use technology or tables to help us. Say that I want to find the probability that z is less than -1.3. So here's -1.3. I want to find this probability. So it's not within our empirical rule to find. So therefore, I can use technology to help me find this. I would go to Graphs, Probability Distribution, and I would want to view probability. I hit OK. I let it know that I'm in the normal distribution, and I give the mean and standard deviation, so I'm in the z table, or the standard normal distribution, and I want to do an x value. It's actually a z value in here, and we were doing -1.3. We were trying to find that probability, and we wanted it to the left of that value. If I hit OK, it will actually show me what the probability that would be. It's 0.09680. So what that would look like is the probability that z is less than -1.3 equals 0.0968. So it would look like that. What if I want the probability that z is greater than 0.35? How would I find that? And this time I want to do greater than, and I use the value that we're looking for, 0.35. I hit OK, and there's that probability. So we would say the probability that z, the number of standard deviations, is 0.35, greater than 0.35 standard deviations from the mean of the standard normal, which is 0, has that probability of 0.3632. So how would we do this if I didn't have technology to help me? Well, we use our standard normal table. And this table is on Elms for You. And we're going to learn how to use this standard normal table. In here, what you see is, here's our z number or z score. So this right here, negative 2.8, is saying z equaling negative 2.8. Up here are the z-score or z numbers hundredths place. So if I wanted to know z equaling negative 2.83, I'd go here and to this 0.3 there. So this and this make up your negative 2.83. So now let's go back to the same problems we did using Minitab, the probability that z is less than 1.3. Well, this standard normal table gives us probabilities of everything less than a particular z-score that we're looking for. So it gives us exactly the problem that we're looking for. But the standard normal table that we use in our class gives us all the probabilities less than a particular z value. We call those cumulative distribution, a cumulative distribution function. So to find the probability z is less than 1.3, that's just like saying the probability that z is less than 1.30. So, and this was, I believe it was negative 1.30. So we go to negative 1.3 here. That's all the things that have negative 1 in the ones place, 3 in the tenths place, and these are all the hundredths place. But in my hundredths place, I have a 0. So this column right here is where I would go down. And where these two things intersect, that is the probability that z is less than negative 1.30. So the answer would be 0.0968. And that's exactly what we got when we used Minitab, of course. So what about the in-between that we looked at? The probability that z is between negative 1.21 and 1.03. Well, I'll have to change my table a bit because we don't see positive 1.03. So let me make it a little bit smaller, but hopefully you can see clearly. So what we're looking for, if we actually looked at the normal distribution, is we're trying to find the probability between being 1.03 standard deviations from the mean in the standard normal distribution and negative 1.21. So we're trying to find that middle part, just like we saw with the output in Minitab. So we're trying to find this. But our table doesn't give us that. Our table will only give us everything less than 1.03. That would be too much probability. So we want to take that 1.03 probability with too much probability in there because the chart only gives me this. So I need to subtract off of that everything less than negative 1.21. And if I did that, wouldn't that just give me exactly what I'm looking for up above? So what we do is we go to the table and we look up the probability that goes with 1.03. So we go here, 1.0. We go down here to the 0.03 column, and where they intersect is right here. So I find that that is 0.8461. And I need to subtract that from negative 1.21. Negative 1.21, that would be this number right here, 0.1131. And when I do that subtraction, I get 0.7330. Whoops, I made a mistake with my first one right here. 1.03 is 8485. Is this right here? 0.8485. So we'll make this correction so we get the correct answer. So you have to be really careful when you're using, you have to be very careful when you're using the standard normal table. I generally tell students to bring a ruler or something so you can go down, make sure you're going down the right column. So this is 8485, which will give us a little bit of a different answer. It would give us, so I'm sorry for that mistake. (7354) is our answer for the in-between. So what you do when you have an in-between, you take the larger of the z-scores, you look for its corresponding probability, and you subtract it from the smaller z-score, just like we did here, and you'll get the in-between because we're subtracting off the probability of the smaller z-score from that probability of the larger to give us the in-between. So now, what about the example when we said the probability z is greater than 0.35? Now my table only gives me everything less than, and there are two options you can take for finding this probability. One is knowing that the area underneath this probability distribution is always 1. So you can determine this by what we call the complement method, or what I call the complement method. That is, we know that the probability that z is greater than 0.35 equals 1 minus the probability that z is less than 0.35. So in other words, we take the distribution, the whole distribution, everything underneath of it, and subtract off of it everything less than 0.35, and we'd be left with exactly what we were looking for, because remember, we were looking for everything greater than 0.035. So you take 1 and you subtract it from everything less than 0.35, and you'll have the piece that you wanted. So what we would do is we'd say 1 minus, and we'd look for 0.35, 0.3, go to the 0.05 down this column here, and we'd have our probability right here, 0.6368. And I would do that calculation, and I would get 0.3632. So that's using what we call the complement method. Now I'm going to use which is a property that the probability underneath any of these probability distributions would equal 1. I'm now going to use that this standard normal distribution and all normal distributions are symmetric. So the second method I'm going to teach you is on the symmetry method for finding the probability that z is greater than 0.35. And that really just relies on the symmetry of the normal distribution, that the area to the right of 0.35 would be the same as the area to the left of negative 0.35, like this. So that would make it that the probability that z is greater than 0.35 equals the probability that z is less than negative 0.35. So when I look up negative 0.035, negative 0.35, going down this column, making sure that I'm down the right row, 0.3632. So it makes it a little bit easier. You don't have to subtract anything from 1 when you use the symmetry method. But both methods are very important to know. So you have to understand both of them. Now it is that some students find one method more understandable than the other at first, but it is important that you learn both methods. So how do we use the standard normal distribution to get from any normal distribution? Use our standard normal table to help us for any normal distribution. So let's say that I've got X. It's normally distributed, again, with a mean of 18 and a standard deviation of 3. And I want to know what's the probability that X is less than 18.2. Well, I can't use my I can't use the empirical rule, but I can find out how many standard deviations 18 is in its distribution. And it's kind of the opposite of when we knew how many standard deviations away and what the variable value would be. That was unstandardizing. Now we want to solve for how many standard deviations away. So if you kind of look at that way of looking at it, the X value was the mean plus how many standard deviations we were looking times what a standard deviation is. We can use some algebra and solve this for finding how many standard deviations any X value is in its distribution. And you would subtract mu from X and divide by the standard deviation, and that would give you how many standard deviations your X value is in its distribution. So the Z-score, or Z number, is how many standard deviations your X value is in its distribution, the distribution it belongs to. So now it's time to look at how we would do it in Minitab, and it's much easier. You go to graph, your probability distribution. You'd make sure that you put down the mean of 18 in here. The mean is 18, standard deviation of 3. If I wanted to look at the in-between of 14.8 and 22, I put those two numbers in, I hit OK, and I see here that I get 0.7657. So during a test, I expect you to be able to use the table and we all will get the same answers. We don't use technology during the test, but technology is more accurate and better to use because accuracy is great. Now sometimes we want to do the opposite. In other words, we don't want to find the probability between X values are greater than or less than these X values, but we want to go and we want to look at a probability and find the X that goes with that. Things like percentiles. So I'm going to first show how to do it in Minitab, and then we'll do it using the table. So what exactly am I looking for? Well, if I say the 97th percentile, that means I'm trying to find the X value such that 97% is to the left of it. So a percentile is that X value such that the probability of everything less than it is 97%. So being in the 97th percentile is good. That means you did better than 97% of the people taking the test or whatever in that respect. We also talk about being in the upper 5% or something like that. Well, that just is the opposite of a percentile. So in here, we're looking for the upper 5%, but that's the same thing as the 95th percentile. So once you learn how to do percentiles, you can do the upper 5%. It's just, you just subtract that from 100 and get 95%, and then you know how to do percentiles. Sometimes we're asked, and we'll need to know, we need to know the X values that such that 95% is in between. And we're going to learn how to do that also. I should have made it a little bit more accurate here. So we want to find these X values such that 95% is in between. And that's not hard to do, because if you do that, you just have to figure out how much is in this area, that is, and you can find the Z-score that goes with that and bring it to the X. So we're going to learn how to do these right now. So the first thing we're going to do using technology is we want to find in the standard normal distribution, we want to find the 95th percentile. So we're trying to find the 95th percentile in the standard normal distribution. So we would go into the same thing we did before, graph, probability distribution, viewing probabilities, but this time for our standard normal distribution with a mean of 0, standard deviation of 1, when we go into the shaded area, we go for the probability. And what do we want? We wanted then 95th percentile, so everything less than it being 95%, or I should say 0.95 when they talk about probabilities. When I hit OK, it's actually going to give me the z-score that it should be, 1.645. So that would be the 95th percentile. And I could also find the 95th percentile for my distribution that had a mean of 18 and a standard deviation of 3. I would just change my mean here to 18 and my standard deviation to 3. I want to find that 95th percentile. So in that distribution, the 95th percentile is 22.93. But now we got to figure out, how do we do this when we're doing a, with the standard normal table? So we're going to learn how to do this with the standard normal table. So in here, remember what we have. Everything less than a z-value. But this is set up for z-scores, not necessarily probabilities. So if I'm trying to find, let's say let's go with the 52nd percentile. So that means I'm trying to find the probability that z is less than this particular z-score, and it's supposed to equal 0.5200. The problem is, when I look into my chart, I don't see 0.5200. I see 0.5. Let's go 0.52. I see this, and I see that. So the closest number I can get in here, the closest probability, and that's the way that we do this, to 5200 is 5199. That's, if I took the decimal places away, that would be 1 away, or this one is 39 away. So I would say the z-score that goes with that is 0.05. So z equals 0.05. That's the 52nd percentile. And now I can know, if I'm looking for the 52nd percentile in that distribution with the mean of 0 and the standard deviation of 3, I already know how to unstandardize. We've learned how to do that. It's at 0.05 standard deviations away. So I say my 52nd percentile is 18 plus 0.05 times what a standard deviation is. So my 52nd percentile is 18.15. Now let's say I wanted to take that case, just like we did before, where I wanted to find the value such that 95% is in the middle. Now we know by the empirical rule it should be about 2 or -2 to 2. But we have a more exact situation here because we can go to the hundreds place. That's just to the units place. So what we're going to do is, how do we find these z-scores? So due to symmetry, this would be z, that would be -z. Well, if there's 95% in the middle, that leaves 5% for both sides. So this has 2.5% on this side and 2.5% on that side. So inside the chart, I'm going to try to find 0.025. and see if I can find that probability inside of here. And when I look inside of here, I see 0.2, and very lucky, this doesn't happen often, I literally see the z-score for that is exactly the probability of 0.025. So it goes with negative 1.96. So this value is negative 1.96, and this value is positive 1.96. So if I wanted to find the two values that such that there's 95% in between the two, these would be the two values. And I can use that in my other distribution, in my x distribution that was normal with a mean of 18 and a standard deviation of 3. My 1x value, my lower x value, will be 18 minus 1.96 times 3. And my upper value would be 18 plus 1.96 times 3. So the two values that would make 95% of the data values in between them would be 12.12 and 23.88. So that's working with the normal distribution, finding probabilities, and then finding the z-scores and the x values that go with particular values. Now, one other thing that I want to show you, which is important, is notation. There's a special notation, and this is the opposite of the percentile. A notation like this, what that means is the probability that z is greater than this particular z value, such that alpha percent is to the right of this z alpha. So what does that mean? What does that look like? It sounded confusing even as I said it. That means I'm looking for a particular z-score such that alpha percent is to the right of it. That darkened area, that percentage is alpha. And we give that a special symbol called z alpha. And that's going to come into play a little later on. But we know how to find that. We can just look up the z-score that goes with alpha to the left of it. Look at alpha up in the body of this chart. Find that z-score, and it would just be the positive one to it. So that's notation that's going to come in handy and be important later on. But just a brief look at it right now. Thank you.